Welcome to Let's Talk Chemistry with Pastor Dan. Today we're looking at formula mass. We get a concept of something called moles, which have to do with how things react chemically, the mass that we use. In order to do that, we start with formula mass. This is the mass of an element or compound based on the formula, and that's what it's massed at the atomic or the very smallest level. Now, the units we use for that are AMUs, atomic mass units. Now, chemists are generally a lazy bunch. We don't want to do the maximum amount of work. We want to get the maximum benefit for the minimum amount of work. So we don't want to write three letters. We want to write one. So you often see it expressed as U's. It means the same thing. Atomic mass units, AMU, U. That's how we do it now. This is the mass of the proton. That's the neutron inside of the structure. All right. So look at an example here. Hopefully you remember this is a covalent molecule, so we're going to use the prefixes CO2, carbon dioxide. All right. So we have carbon and oxygen. Looking at the formula, I have one carbon, two oxygens. Looking at the periodic chart, okay, look at the periodic chart, we find carbon atomic mass of 12 AMUs. Oxygen has 16 AMUs. Now, we multiply through. 1 times 12 is 12 AMUs. 2 times 16 is 32 AMUs. Add them together, 44 AMUs. That's a formula mass. And you go, wait a minute. Look at the periodic chart. Carbon's 12.011. Oxygen's 15.999. Remember, that's from the abundance. That's all the averages, all different isotopes. I usually make a rule to make life easier. We're going to round it always to a whole number. And the reason for that is because most isotopes have one major element, and that's the one that is the atomic mass based off of. Now, there are two exceptions. Okay, those exceptions are copper and chlorine. Now, those have to do with their isotopes, and their copper has two major isotopes, copper 63, copper 64, so we're going to make copper 63.5 AMUs. Chlorine has two major isotopes, 35 and 36, so make it 35.5 AMUs. That's when we do it, and that's due to the abundance of how those isotopes work. So you may go to a professor in college where they want you to use the entire number. That's fine. I just find it works easier and doesn't make that much of a difference when we work with the numbers to make it the way I'm showing you now. So hopefully it makes it easier for you. All right, so let's look at this. We have NaC2H3O2. What's the name on that? Remember, this is a polyatomic. Remember, Na is sodium, and if you have that list or memorized C2H3O2, that's acetate, so that's sodium acetate. We have NaC, carbon, H, hydrogen, O, oxygen, of course, Na is sodium. We have 1 sodium, 2 carbons, 3 hydrogens, and 2 oxygens. Going to multiply. From the periodic chart, sodium is 23 AMUs. From the periodic chart, carbon is 12, hydrogen is 1, oxygen is 16. We multiply through. 1 times 23 is 23 AMUs. 2 times 12 is 24 AMUs. 3 times 1 is 3 AMUs. 2 times 16 is 32 AMUs. Add them up, 82 AMUs. All right, let's try next one. Al2SO4, can we try that one? Again, it's another polyatomic, but now we're using the box rule. Inside or outside the box? Remember, it's inside. Inside O4, is that an 8 or an 8? That's an 8. So it's sulfate. So this is aluminum sulfate. We have aluminum, sulfur, and oxygen there. How many do we have? We have 2 aluminums. That makes sense. Now, this next one's a little bit of a challenge here. We have 1 S in SO4, but I have a 3 outside. So we got to multiply through. 3 times 1, I have 3 sulfurs. Now, 4 times 3, I have 12 oxygens. So we have to multiply through. We have 2 aluminums, 3 sulfurs, and 12 oxygens. Atomic mass in the periodic chart, aluminum is 27U, sulfur is 32U, oxygen is 16U. Multiply through, we get 54U, 96U, and 192U. Stop. Add them up, see what you get. You should get 342U. All right, let's try making this a little bit harder. Not too much, and hopefully you still remember to do this. Let's go from the formulas, from the nomenclature to write the formulas. Okay, so iron to nitrate. What's the symbol for iron? Iron's Fe. Nitrate, inside or outside my box? Nitrate's outside the box. So 8's outside the box are O3, so we have NO3. Charges there. Remember, we don't know iron, so from the number, it's +2. Nitrate, remember we go -1, -2, -3, hit the wall of the box, start over for nitrate. It's -1. That doesn't equal 0, so we swap them down. We get Fe parentheses NO3 twice. We have 3 elements here: iron, nitrogen, and oxygen. From the formula, we have no number there, so it's assumed to be 1 iron. We multiply through. I have 2 nitrogens and 3 times 2, 6 oxygens. React chart, it's 56 for iron, 14 for nitrogen, 16 for oxygen. Multiply through. I'm going to get 56, 28, 96. Add those all up, 180U. Let's look at the last one here. Silver dichromate. Silver. Silver's symbol is Ag. Now, is dichromate inside or outside the box? Neither. What do you mean neither? Remember, chromate is a metal. Box rule only applies to non-metals. So therefore, we have to look at that list from the ones we memorize. Dichromate, Cr2O7. Oxidation numbers. We don't have a number there, so we're supposed to know it. Periodic chart, remember the steps: silver, zinc, aluminum. Silver is +1. And chromate from that list, -2 doesn't equal 0. Cross it down, Cr2, Ag2, Cr2O7. Elements, Ag, Cr, and O. We have 2 Ags, 2 Crs, 7 Os, multiplied by 108 Us, periodic chart, 52 Us for chromium, 16 Us for oxygen, multiply through. I get 216U, 104U, and 112U. Add those all up, and we get 432U. All right, I have 4 problems I want you to work through. Pause the video, do these, see what you come up with. Okay? All right. You good? All right, here we go. So for the first one, the answer is 143.5. Remember, chlorine at 0.5. Number 2, the answer is 310U. 4, the formula is PbNO3 3 times. So the answer is 393 U's. Remember, for the last one down here, copper is also 0.5, so it's 127, not 126. So the answer is 415U. All right, hopefully that wasn't too bad. Take care, be good. God bless.